Load balancers. What are they? How do they help you? What do they do? Let's get into it. So, for the sake of this, let's imagine you are running a website currently, or a piece of software that requires a backend that users will connect to. Let's look at the right here. So, let's say you have 4 current users, or however many you want them to represent. They will all connect through the internet to your app server on the backend. Now, this is all fine and dandy if you have 4 users and a large enough server, but now let's say you've got 400 users, 4,000 users, 400,000 users. As you scale up, you can only go so big on your app server before it starts to lag, crash because there's too much traffic, become overloaded, and start causing general issues with your reliability on your application. Uh, so what do now? You've got more users. You can size up the app server, right? But at some point, it becomes not economically viable because the hardware is way too expensive, or you just run out of physical space. There's only so big a server can be before there's no more better processors, no faster processors, no more RAM you can put in it. The motherboard can't handle it. So you've expanded as much as you can that way. Now what? This is where a load balancer would come in. So let's start with our same users here. We go through the internet, same as before. Nothing changes for them. Then we have our load balancer here. This is a piece of software or hardware in between the internet and your app servers. What this does is it spreads the load out between multiple servers. So rather than expanding just the one server and making it extremely large, what you've done now is have multiple smaller app servers or even multiple of the same size app servers that will handle all the requests. So in this example, we've gone from 1 app server to 4 app servers. Basically, there's a few different ways that this works. One, meaning you can go round robin style. You could go, okay, user 1 comes in, they go to server 1, user 2, server 2, so on and so forth. You could do the load balancer could do a strategy like who's got the least number of connections currently active. So let's say app server 1's got 1,000, but for some reason app server 4 has only 100. Okay, if app server 4 has the least, it'll start passing people there to try to keep the load balanced between them. So that way one app server is not going to cause issues. It's also nice, let's say if app server 2 goes down, well, on the other example, you'd only have one app server. If that goes down, you're done for. Your app is toast. On this, we can account for that. Our load balancer can notice that app server 2 is down. We're not going to pass any traffic to app server 2. We're only going to go through 1, 3, and 4. Now this increases your reliability and your uptime, because now, if for some reason this is something that's going to happen to the others, you have time to figure out, hey, why is app server 2 causing issues? Let's see if we can figure that out, fix it before it happens again. And this also helps you save money too, since now you're not buying the best of the best of the best hardware that's going to cost a fortune. You can run smaller servers and increase and decrease as needed using certain applications like Kubernetes and have it automatically expand up and down, but that's getting off into the weeds. But load balancers can also go a little further as well. If for some reason you want one server to handle internal traffic and one to handle external traffic or things like that, load balancers can look at layer 7 load balancers can look at like HTTP data and the headers and that kind of thing, and cookies. That way you can kind of sort it by that if you'd like, or really anything of that nature. But overall here, a load balancer increases your reliability, increases your scalability by allowing you to scale horizontally, and increases user satisfaction if you're having troubles with your one app server being overloaded. Anyway, that's all we have for you today. Thanks for watching. Please remember to like and subscribe.